In this video, we're going to talk about how to solve problems using the student's T distribution table. So let's focus on this one. Number one, the average weight of 20 students in a certain school was found to be 165 pounds with a standard deviation of 4.5. Part A, construct a 95% confidence interval for the population mean. So let's write down what we know. So we know that the average weight, or the sample mean, is 165 pounds. The sample size is 20. The average weight of 20 students was measured in this study. Now, the standard deviation is 4.5, but here's a question for you. What type of standard deviation are we dealing with? Is this the sample standard deviation, or is this the population standard deviation? What would you say? Now, a typical school is going to have more than 20 students. A typical school might have 1,000 students or 4,000 students. So the 20 students in our study represents a small sample of all of the students in the school. So therefore, this is the sample standard deviation, which is 4.5. Now, when you have a question like this on a test, you need to determine if you need to use a normal distribution or a student's T distribution to solve it. Now, based on the title of this video, you know it's going to be the student's T distribution, but you need to know why you should use which one. When you know the population standard deviation, typically you want to use the normal distribution. But we don't have the population standard deviation. We have the sample standard deviation. And that's one indication that we need to use the student's T distribution to construct the confidence interval. But there's something else that we need to consider as well. And that is the sample size. When n is equal to or greater than 30, then it's a good indication that you want to use the normal distribution. But in this example, n is less than 30. So that tells us that we want to use the student's T distribution instead. So those are two good indicators that you should use the student's T distribution. If you have the sample standard deviation as opposed to the population standard deviation, and if n is less than 30. Now, the population mean is going to be within the sample mean, x bar, plus or minus the t-score. This is t sub nu sub alpha over 2, which we'll talk about what that is, times the sample standard deviation divided by the square root of n. So we have x bar, we know what s is, and we know what n is. In order to construct the confidence interval, we need to determine the value of our t-score or t-value. The subscript nu, that's the Greek letter nu, looks like a v, that's equal to n minus 1, which represents the degrees of freedom. N is 20 in this example, so 20 minus 1 is 19. So I'm going to write this here. So we have 19 degrees of freedom. Alpha over 2, this is the 1-tail alpha. The 2-tail alpha is just alpha, by the way. But our 1-tail alpha value, alpha over 2, that's going to be 1 minus the confidence level divided by 2. Now the confidence level is 95%, but as a decimal, if you divide it by 100, it's going to be 0.95. 1 minus 0.95 is 0.05. And if we divide that by 2, that's going to be 0.025. So that is our 1-tail alpha value. Now, just so you can get a visual illustration of this, let's say we have a graph that looks like that. I'm going to shade two regions. So this area to the right, this is alpha over 2. So that's our 1-tail alpha. On the left, this is also alpha over 2. Combined, if you add them together, that would be alpha. And in the middle, this is 1 minus alpha. So just know that alpha in this example is 0.05, but alpha over 2, the one-tailed alpha is 0.025. So now we could determine our t-value. So we have 19 degrees of freedom with a one-tailed alpha value of 0.025. So at this point, you want to go to the student's t-distribution table and find the value that corresponds to a new value of 19 and an alpha over 2 value of 0.025. And I'm going to show you how to do that briefly. So here we have the student's t-distribution table, and we said that we had 19 degrees of freedom and an alpha over 2 value of 0.025. So if we find the intersecting row and column, it gives us this number, 2.093. And so that's going to be our t-value when we have 19 degrees of freedom and an alpha over 2 value of 0.025. It's equal to 2.093. So now let's write our t-value of 2.093 here. So now let's follow this expression to construct the confidence interval. So let's replace x bar with 165. Our t-value is 2.093, and s is 4.5, n is 20. 2.093 times 4.5, that's 9.4185. And then divide that by the square root of 20. You're going to get 165 plus or minus 2.106. Now, this number here has significance. That is our EBM for the population mean, which is also the margin of error. So if you want to write this down, the EBM for this type of problem is going to be our t-value times s over the square root of n, which gave us that number. Now, to construct the 95% confidence interval, it's going to be the sample mean minus the EBM value, and then the sample mean plus the EBM value. So once you get to this part, you already have the answer for part B, which is 2.106. So now 165 minus 2.106, that is 162.894, and then 165 plus 2.106, that's 167.106. So this right here is our 95% confidence interval. So what does this mean? This means that we're 95% confident that the average weight of all the students in this school is somewhere between 162.894 and 167.106. So that's how you can construct a confidence interval using the student's t-distribution table. That's it for this problem. Number 2, a chemistry class at a certain university has 500 students. The scores of 10 students were selected at random and are shown in the table below. Part A, calculate the mean and standard deviation of the sample. So let's start with that. So the sample mean, x bar, is going to be the sum of all 10 scores of the students divided by the sample size. So we're going to add 76 plus 84 plus 69 and so forth. By the way, if you want to try this problem, feel free to pause the video and work on it. And then when you're done, you can just play the video to see if you have the same answer that I have. So the sum that I got is 800. If we divide it by 10, we get 80, which is a nice number to deal with. So that's the sample mean. That's the first part of part A. Now the next thing we need to do is calculate the standard deviation of the sample. And so the formula that we're going to use to do that is going to be S is equal to the square root of the sum of x minus x bar squared over n minus 1. So x will be the individual values that we see here in the table. X bar is 80. So the first value is 76. We're going to subtract it by the mean and then square the result. The next value is 84. Subtracted by the mean, square the result. The next value is 69, and then we're going to repeat the process until we include all 10 values. So I'm going to put dot dot dot. You can finish the rest, and then I'll put the last one as well. So it's 77 minus 80 squared divided by n minus 1. So that could take some time writing all of that out. But if you want to show your work with less writing, here's what you could do. So 76 minus the mean, 76 minus 80 is negative 4. But when you square negative 4, it's going to be positive 16. So I'm going to write 4 squared for the first one. The second one, 84 minus 80, that's going to be 4. And then we're going to square it as well. Now let's take this number and subtract it by the mean. The difference between 69 and 80 is 11. 92 is 12 units from the mean. 58, that's 22 units from the mean. 89 is 9 units away from it, so this is going to be 9 squared. And then 73 is 7 units away from the mean. Once you square it, the negative signs won't matter. 97 minus 80, that's 17. And then 85 minus 80 is 5. And then 77 minus 80, that's negative 3, but we're going to make it positive. And then divide it by 9. So go ahead and plug this in to your calculator and see what answer you get. So I got, for the sample standard deviation, 11.709. So that's the second part of part A. So now let's move on to part B. Now let's also write that n is equal to 10. Part B, calculate the margin of error, the EBM. We could use this formula to calculate the EBM. It's equal to our t-value times this sample standard deviation over the square root of n. So we need to calculate our t-value first. So v, that's n minus 1. So that's 10 minus 1, which is 9. So we have 9 degrees of freedom. And then we need to calculate our one-tail alpha value, which is 1 minus the confidence level divided by 2. So in part C, we want to construct a 90% confidence interval. That's going to be 0.9. 1 minus 0.9 is 0.10. And 0.10 divided by 2 is 0.05. So our alpha over 2 value is going to be 0.05. So now let's use that table that we used before and find the t-value where we have 9 degrees of freedom and a one-tail alpha value of 0.05. So here we're back to our student's t distribution table, and we have 9 degrees of freedom and an alpha over 2 value of 0.05. So we can see that that's going to give us this number, 1.8331. So when we have 9 degrees of freedom and an alpha over 2 value of 0.05, this is going to be our t-score, 1.8331. So let's go ahead and write it here. So now let's calculate the EBM value. So it's 1.8331 and then times S, which is 11.709, divided by the square root of 10. And so that comes out to be 6.787. So that is the margin of error. That's the error bound for the population mean. That's it for part B. Now let's move on to part C. Construct a 90% confidence interval for the mean score of all the students in the chemistry class. So we know the mean is going to be somewhere between x bar plus or minus our t value times s over the square root of n. And so we know that x bar is 80, and all of this, which is our EBM value, that's 6.787. So the 90% confidence interval is going to be between x bar minus EBM, and the maximum value will be x bar plus the margin of error. So this is going to be 80 minus 6.787, and then 80 plus 6.787. So 80 minus 6.787, that's 73.213. And then 80 plus that number, that's going to be 86.787. So this right here is our 90% confidence interval. So we're 90% confident that the mean score of all the students in the chemistry class is somewhere between 73.213 and 86.787. So that's it for this video. Thanks for watching. If you like it, don't forget to subscribe.